I'll start. So today we'll be discussing about hidden Markov model. Okay, so this is just a probabilistic model which can be used for a specific type of problem. So hidden Markov model is basically a statistical Markov model in which the system being modeled is assumed to be a Markov process. What is the Markov process? It is basically a sequence of events in which the events are dependent on the previously happened events. Okay, so why it is called event? Why it is called hidden? It is just because there are some unobservable states which the observer cannot see, but the events are somewhat dependent on those unobserved states. I'll be showing the example or demonstrating the example on the basis of which you will be able to know how the hidden Markov model works. Okay, so our goal is basically to learn about observing. So whatever we observe, whatever we perceive, we have some inference of it. Okay, so that's what the hidden Markov model is all about. Yes, as I said, Markov process, this is a sequence of events happening in which the present event is kind of dependent on the previous event happened with some probabilities shown in this small diagram. So we have this E one event and A is another event. The probability of A given E is there, E has happened. We can calculate using the Bayes theorem and all. I'll be discussing that also. So how to calculate and how to infer everything. Okay. So the applications are, as I said, it is basically used for the sequence of for the applications where the sequence is important and the present state is dependent upon kind of a previous state happened. So like tagging of part of speech. Let's say we have this sentence: the waiter cleared the plates from the table, right? So we need to identify whether which one is the determinant, preposition, verb, and noun. So it can be used for that. Robot localization, knowing the location of the robot or identifying the path of the robot based on the previous experiences. So you can do that. The same thing which you've been given into the assignment. You can also use HMO model we have for that for the implementation. For the genetics part, definitely there is a lot to infer from the genetics algorithm. You can look for it in detail. I'm not very well known of it, right? It is used for that basically. Similarly for the speech recognition, right, and so on. There are a number of applications out there. So I'll start with the example only. Let us say we have two people. One is Bob and one is Alice. So Bob calls Alice and tells whether he's happy or sad, and based on that, she infers whether the weather at Bob is sunny or rainy, right? So in this way, so let's say Bob says, "यार मैं तो आज खुश हूँ," ठीक है? Then फिर Alice ये पता लगाती है कि yes उसके यहाँ पे sunny होगा. That's why he is happy. Okay. And in same way, if it is rainy, then he gets sad. And फिर Alice बोलती कि हाँ वो sad है तो इसका मतलब वहाँ पे rain पड़ रही है. ठीक है? So we have this two weather, sunny and rainy, and we have this two thing, happiness and sadness, which we call it grumpy. Okay. And whenever there is whenever there is sunny, then the Bob will be happy. If it is rainy, the Bob will be sad. But it is not actually possible practically every time that जब भी sunny होगा तब वो always happy होगा और जब भी rainy होगा तब वो always sad होगा. So there are some exceptional cases as well. So let us consider we have this model. So 80% of the time, let's say जब भी sunny होगा तो जो Bob होगा वो happy होगा और 20% of the time वो sad होगा. In the same way rainy के लिए. I hope everything is fine. Okay, yeah, sure. Yeah. So now the Bob is, let's say the Bob communicates to Alice, he's happy, sad, happy. Okay. So Alice then infer that there must be sunny, rainy, sunny. Okay. So so on. So let's say we have 6 days sequence. Let's say Monday he was happy, Tuesday he was sad, and so on. And Alice kind of determined whether it was sunny, rainy, sunny, rainy. But practically, you see, it is not possible, like it is not feasible that one day it will be sunny, the other day it will be rainy, and this sequence keeps on continuing, right? So there should be a model which should like demonstrate the realistic behind this all this, or the predictability should be accurate, right? So hidden Markov model is kind of that. So as we discussed all this, so these are the probabilities which are observable, and these are the hidden probabilities which are not known to the LS. Like sunny hai to next time bhi sunny hoga, so it has a probability of 0.8, and if it is sunny and the next day is rainy, so 0.2 probability is there, so and so on. Okay. So these are the hidden states and these are the observations. Okay. So the probabilities mentioned over here are called transition probabilities, and the emissions mentioned and the probabilities mentioned here are called emission probabilities. Okay. So in total, this is called the hidden Markov model. So there are some hidden states and there are some observable states. Okay. Now we'll address these four questions. So how do we know these probabilities? How do we calculate actually these probabilities? Okay. Then what's the probability that a random day is sunny or rainy? So it is all about the probability. Okay. So we'll be discussing the Bayesian theory. We'll be discussing Viterbi algorithm as a dynamic programming concept, and so on. And then we'll be discussing if the Bob is happy today, what is the probability that it is sunny or rainy? And the last question, for the 3 days, Bob is happy, grumpy, happy. And what was the weather? So this thing we'll be discussing further. Okay. So let's say we have the data. So how do we find the probabilities? The first question was, so let's say we have this data of 15 days. Out of this, let's say 4 days it was sunny. Then after that, 3 days it was rainy, 4 days sunny, and so on, as you can see. Now, if we calculate sunny to sunny transitions, we can observe 8 times it had happened, and sunny to rainy transitions, it had happened 2 times. So the probability of sunny given the previous day was sunny was is 0.8, and the probability of sunny given the previous day was rainy is zero point 0.2. Similarly, for the rainy, you can see 0.4 and zero point 0.6. So remember these probabilities. Okay, these are what we infer from the data which we had. Okay. उसके बाद let us consider for the same for the happiness and grumpiness for the Bob. Okay, we have the data, and it is observed that when it is sunny, he is happy 80% of the time. When it is sunny, he is not happy 20% of the time. Okay, so on the basis of these, we have calculated these probabilities. Yeah, so in this way, we have got these hidden as well as observable probabilities. Right now, let's say Alice does not communicate anything to Bob does not communicate anything to the Alice that it will be rainy or sunny. So Alice have an basic idea that there are two-third of the probability that it could be sunny, and 1/3 of the probability that it could be rainy, right? So in this case, let's say 15 out of 15 days, so 10 days were sunny and 5 days were rainy. So that's why she was able to know 2/3 of the days were sunny and 1/3 of the days were rainy. So after knowing this, now she can actually know without even getting any information from the Bob, that there are more probabilities that it could be sunny than the rainy, right? So we can represent this thing in this way. So let's say we have we'll figure out the set of equations. Now we need to find the probabilities like 2/3 and 1/3. We calculated using the normal the standard probability method, like the number of observable state and total number of observations, right? If we need to calculate from this model, this Markov model, then how do we do that? Let's say we are here, so the equation for this will be s equal to zero point 0.8 into s, okay, plus zero point 0.4 into r. Similarly for r, and make sure that the summation of s plus r should be equal to 1. That is, if the probability of s is probability of sunny is zero point 0.8, the probability of rainy should be zero point 0.2. Okay, so that should be 1. And when we solve this probability, we'll be able to find the probability of sunny is 0.67, that is 2 by 3, and probability of rainy is 0.33, that is 1 by 3. Okay, so this way we figure out what is the probability that any random day it will be sunny or rainy. Now the question comes, if the Bob is happy today, what is the probability that it is sunny or rainy? Okay, now let's say she knows, she have this idea that 2/3 of the time it will be sunny and 1 time it will be rainy. Okay, now the Bob says he is happy. Okay, on the basis of that, she figures out that out of 5 times, 4 times it would be sunny, and 1 time it would be rainy, as the probability was 2/3, that is 67%, right? And if he says he was sad, then 2/3 of the time it will be sunny, and 2/5 of the time it will be sunny, and 3/5 of the time will be rainy. Okay. Now, let's say today he was feeling happy. So there are two possibilities. Either he would be sunny, either he would be rainy. If we consider the standard thing, we can come to the conclusion that it is sunny. But now we have a probabilistic model. We need to actually figure out how it can be done, right? So we'll calculate the probabilities. Let's say we have these probabilities, 2/3. These are called prior probabilities, 2/3 and 1/3. Okay, and we have this calculated probabilities. Okay, and further, if we need to calculate, we'll use the Bayes theorem for that. Okay, let us say we have 3 days, sunny, sunny, and rainy. We have the probabilities that 2/3 of the time it will be sunny, 1/3 of the time it will be rainy. Okay, and if it is sunny and there are 5 days, okay, if it is sunny, total 15 days are there, right? If it is sunny, 4 times of the time it is happy, and 1 time it is sad. Similarly for the next day, and similarly for the rainy. If we calculate in total using the Bayes theorem, the probability of sunny given he was happy and probability of sunny given he was sad, we can calculate using the Bayes theorem, as you can see over here. So total number of possibilities when it was actually sunny. Okay, probability of sunny when given happiness. So total number of observations are 10. Okay, sunny ka or rainy ka, as well as when he was happy and it was sunny. So there are 8 possible cases. So the posterior probability, we can call it as 8/10, that is 0.8. Similarly for the rainy, it is 2/10. And in the same way, we can calculate it for grumpiness. Okay. So in this way, we answered this third question. Now the final question: if for the 3 days Bob is happy, grumpy, happy. Now we are told that he was happy, grumpy, happy. So we need to identify that what was the weather. That too mathematically. Okay. So standard state में क्या होगा कि if the Bob says he was happy, sad, happy, then she'll infer that it was sunny, rainy, sunny, right? But now as we discussed, that it is not pre-decided. We need to have some mathematical uh, proof to conclude it, right? So let's say we have 2 days, Wednesday and Thursday. The possibilities for the Wednesdays are sunny, rainy. Similarly for the Thursdays are sunny, rainy. So for the 2 days, it can be the combination can be sunny, 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 rainy, 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 and rainy, sunny, as shown in the here. Okay, as shown in the figure. So sunny, 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 rainy, rainy, sunny, and rainy, rainy. So these are 4 probabilities as we are calculating for the 2 days. Okay. Now let us consider one state, that is sunny to rainy. Okay, this is sunny, this is rainy. Next day it was rainy. So as we have this information that on Wednesday he was happy and on Thursday he was sad, the probability of sunny is 0.67. Okay, probability he was happy given it was sunny, that is 0.8, and probability of next day it will be rainy, that is 0.2, as we calculated earlier. And the probability that he is grumpy given it was rainy, that is 0.6. So for calculating this particular scenario, that is for the day one it was sunny and day two it was rainy, if we need to calculate what could be the probability of this particular event happening, we need to multiply all these probabilities. Okay, that is 0.8, 0.6, 0.67, 0.2, 0.6. So we get 0.64. If we calculate this particular thing for all the possibilities, we'll get that the maximum chances occurring for this state, that is sunny, sunny. So 0.85 is there. Okay, for sunny, rainy, we calculated 0.064. For rainy, sunny, it was 0.0107. And you can calculate to get the idea, to get the brief idea about it. Okay, so we get this. Okay, so if he says now that he was happy and sad, then the Alice infer that it was sunny, sunny, based on the probability. Okay, now let us consider for 3 days: Wednesday, Thursday, Friday. So on Wednesday he was happy, on Thursday he was sad, on Friday he was happy. Okay, so the number of probabilities will get 9, 2 raised to power 3. As we have two possibilities, sunny and rainy, that's the 2 to power 3. So there are total nine, sorry, 3 power 2. So there are total nine probabilities, nine possibilities. Okay, sunny, 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 and so on till rainy, rainy, rainy. Okay, now we need to calculate probabilities for all this as we did in the previous example. So 0.67, then zero point 0.2, zero point 0.3. As you can see, these all probabilities are well known. So we just need to multiply all this, and we get the score. If we calculate all for all the possibilities, we will come to know that this particular sequence is having maximum probability to occur. Okay, sunny, sunny, sunny. Now if the problem gets tougher, like 4, okay, it will become 64, 16. Okay, so Markov model it will be using. So let's say if it gets 6, then it will get 64 possibilities. So we need to calculate for all these 64 cases. So it will be difficult and time consuming, right? So for that, there is one dynamic program concept known as Viterbi algorithm. So this can be used to calculate that. So how it can be done? Let's say we have this sequence, right? So for Monday he was happy, for Tuesday he was happy, Wednesday, and so on. Okay, so there can be number of cases as here discussed, as shown. There can be number of cases, right? A number of possible combinations. That is 64. Okay, anything can happen. So let's say we need to calculate for this, and these are the all the previous section probabilities. So we need to basically find out the best path till here, and after that we'll calculate this. So how do we find the best path till here? Okay, so that's what where the Viterbi algorithm comes into picture. How to calculate? So as shown in the previous section, we have sunny. Okay, for the probability for sunny is 0.67, and if it is sunny and he was happy, then it is zero point 0.8. Okay, and similarly sunny to next day be sunny, it was zero point 0.8, and if it is sunny and he was happy is zero point 0.8. If you multiply all this, we'll get 0.533. Similarly for rainy, will get 0.133. So for rainy, how it will be? So when it is rainy and he was sad, it is zero point 0.4. When it is rainy, he was the next day is sunny. It was the probabilities, So we just need to multiply that, and we will get this course. Similarly, for the next state, let's say, as I said, so 0.133, zero point 0.4 into zero point 0.8, and this particular sequence. So whichever maximum comes, it will get the probability of that particular event happening. Okay. So in this way, we can calculate for all these combinations, and we can actually know that the actual most probable sequence that can be happen. Okay, so for this, for Monday, we have sunny is the maximum probability 0.533. For Tuesday, again, sunny. For Wednesday, again, sunny. But for Thursday, as you can see, he was continuously sad. That's why the probability of getting sunny is decreased, and probability of getting rainy has been increased, and now it is more than the probability of sunny. So now sunny, 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 then rainy, and then again sunny. Okay, so in this way, this is the path which is actually shown. So in this way, we can actually calculate for the higher number of like cases. Here we had 64 cases, right? So we need not to calculate for all this. This is very short thing, and this is how we get the sequence. So I hope you get the drift, right? So I'll be sharing the reference document for this, and
Yes.
if any questions are there, I can ask. Any questions, guys? So I'll be sharing this PPT as well, and the reference videos which I've taken. So this particular thing I've taken from a lecture from Udacity. So I'll be sharing that too, to understand this thing in detail. So isn't it doable with simple properties? No, Sushil, it cannot be. Like it is basically it is inferred from the probabilities concept. But if you see, there are hidden states. So we are not known. If we see the simple probabilistic problem, so what we have, number of observable states upon total number of observation, like observed upon total number of observation, right? Here we do not have that particular thing. there is dependencies on the previous events. So that's why the probabilistic model gets upgraded and it becomes complex as the variables and stuff's getting added to it. So Bayesian inferencing is very important. I guess your next assignment will be on that. So you need to make sure that your probabilistic concepts are clear. Any questions? Okay, then I'll stop sharing then. Yes, Arpit can continue here onwards.
Good afternoon to everyone. Am I audible? Just a minute, I am sharing my content. Okay. Now we are starting with the Kalman filter. Hi everyone, I am Marpijan. We'll going towards the Kalman filter. Kalman filter is an algorithm that provides the estimation of some unknown variables given the measurement observed over the time. Means it is basically a mathematical tool to extract, predict some of the feature by already knowing the some attributes of the real time. That is a Kalman filter. Now, why we are using this? Means what are the application of the Kalman filter in a real life? It is used for the guidance and the navigation when without using of GPS. It is also helpful, very helpful in the especially in the aircraft for the controlling of the vehicle where we can't apply the GPS system or something the normal that we are applying on our bikes and road vehicles. Also, it involves using of camera to perform the real-time image processing for the vehicle tracking. Basically, it is a tool by which we can calculate or predict the future prospect from the past or the present uh, variables. Now we are coming to how we are going to use this. As I have told that it is a mathematical tool. It is basically deal with the two background knowledge. First is estimation theory and other is a Gaussian or the normal distribution. Now what is Gaussian distribution? It consists of two parts, means mean, which is an average, and other is a variance, which is basically tell you how much the number are spread over and how far they are from the mean. Now this is the basic concept that is used in a Kalman's filter. Now, how the Gaussian is related to the Kalman filter? I am just giving you the overview now. We'll go into the more detail afterwards. Yeah, how the Gaussian is related to the Kalman filter. A Gaussian in a Kalman filter represents the predicted with a noise or the error in our prediction, often known as the variance. The predicted value is centered about the mean, which with the width of the Gaussian denoting the uncertainty in the value. Basically, it tells us how much sure we are for the certain value to be the true. More the width of the Gaussian, more would be the uncertainty. Here I have shown the there are two steps, predict step and the updated step. First stage is predict stage, which we called as a propagation, and other one is a updated, on which we do the correction. Now coming to each step of the iteration, means it is an iterated process. Again, we are doing the same step to reduce the error nearly to the zero. In predict value, we just predict the new value called the predicted value, which is based on the initial value, and then predict the uncertainty, which is error in our prediction according to the various processes or the noise present in a system. While in update, we take an account of the actual measurement coming from the devices, and we call it as a measured value. Here, we calculate the difference between the predicted value and the measured value, and then decide which value to keep for calculating the Kalman filter, because our main process, first perspective is to calculate the Kalman filter, which would be calculated from the error in the estimation and error in the data. And data what we are getting, it is a measured or the input data that we are getting from the surrounding. Now, what is from here we are calculating the Kalman gain. Now, what is Kalman gain? It is a parameter which decide how much weight should be given to the predicted value and the measured value. How much importance should be given to each value. It is a parameter that decides whether our actual value is close to the predicted value or the measured value is close to the predicted value. The Kalman gain, the range of the Kalman gain is 0 to 1. If we have a large error in the measurement, then K is near to 0. What we can infer from this is the predicted value is close to the actual value. Or if the K is closer to the 1, it means that we have a large error in the prediction. What we can infer is our measured value is closer to the actual value. Now, after calculating the Kalman's gain, we are coming to the calculating the current estimation, which is calculated from the previous estimation and the measured value. From both of this, the output of the Kalman gain and the calculated value of the current estimated, we are going to calculate the new error in the estimation. Means what is the estimated value after taking the original error and the original estimation. This is the and now from this value we are going to update the estimate. We are going to update the estimated value. So this is the process of the each iteration. Means in each this is the iterated value for the number of times we are going to follow the same value. The main perspective of iteration is to let's suppose first we have assumed that it is a position of the vehicle, and we are going to predict the future value. Means after 10 minutes, how we are going to where that vehicle would be. So the parameter would be the speed, the time it is going to time it is taking, the acceleration we are going to take, and the rotation of the wheel, axis of the wheel. So from that we are going to calculate the predict the value for after the 10 minutes. For suppose we have calculated the x distance and the x point. So this is our estimated value, and from that estimated value we have the input data also, which is the present data. After calculating the Kalman's gain and the current estimation, we are going to calculate the error, and from that for each step we are going to do the same process from 0 to the 10th minute. That is our destination. So likewise we are doing the same process. Basically it is a mathematical tool, so it requires the basic understanding of the Gaussian and the normal distribution. Let me go you through the equations which is used in the prediction and the measurement update, as these are the two features, two major categories which lie in a Kalman filter. So Sushil, it is I have given the example of the estimation of the predict the vehicle after the 10 minutes, that is used in the GPS system. Means if we are in a surround where we are using the normally we are not using the Kalman filter for the GPS system, where we are using it means by the help of sensor we are getting the input, we are getting the surrounding information. And if the GPS is not working, means if we are going in a long way tunnel where where the internet facility is not there, so our information cannot be diverted uh, to our server, and we cannot map it to our local device. So in that, we are using the Kalman's filter for calculating the for calculation of the predicting the value for the after 10 second or 30 second, whatever our desired value. So how we are doing? We are using with the help of the Gaussian filter that I have explained here by using the iteration process. This is our original estimation, and this is our input data that I have told you about, that I have indicated about the velocity of the input data can be velocity and the time and the rotation of the wheel axis length. By the help of that, we can use the incorporate the input data, and from that we are calculating the Kalman's gain and the measured value. From that we are estimating the value in each iteration. So this is basically the overview of this. Uh, I know that you after from this equation we cannot predict anything because this is little bit. So this, as this is a multivariable Gaussian filter, so we have to go to the that only. That was just an overview. So this is a rough way of calculating the for predicting the value and for updating the value. Okay. So here we stop for that, and we are you can ask the question. No, ma'am, I don't have the program demo right now. It is in MATLAB, so it was not possible to incorporate here.
Yeah, so am I audible? So I'll show you we had one assignment for this, like carbon filter for the trajectory prediction. So I'll just show you an overview about it. Is it visible? Is it visible? Yes. Okay. So we had this sequence like 30 seconds video which were divided into number of sequence. Okay, so we were asked to basically plot the trajectories which was followed by the car, which was actually traced by the car. So these were the trajectories. So how we did that? So basically we need to track the object first. So how I did, I basically filtered out the location of the car by actually subtracting the reference image, reference frame with the video frame, and there I got the actual object. Then I took the center of it, and as the video proceeds, the algorithm, basically Kalman filter algorithm, is basically able to track it. Basically it traces it, and it is basically creating this cross design, as you can see. So I'll share this thing also with you, how to implement the Kalman filter. So this was done in my like in our initial days. So it was quite nice. So I'll be sharing this too. So this was one of the example for the trajectory prediction. Yes, I'll include those steps in the document which I'll be sharing. It is quite mathematically shown, so that's why it is not possible to actually tell them how it is done. Yeah, so basically we were given a video footage. Yeah, Sushil. So basically we were given a video footage of 30 seconds. Okay. So what we did, we split that footage into frames, sequence of frames. So uh, we had a reference image. So you can see all these cars are stationary, right? These are not moving. Only one object is moving. Okay, only this object. So initially, the object was over here. It went on like this. Okay, so we had one reference image in which this car was not present, and when this car came into picture, we basically subtracted these both images, and then but first you need to convert it into the binary, so to make the calculations easier. Okay, binary or grayscale. So when you actually subtract those reference image to the image in which the car is shown, then you will actually get the image of the object only, and subtracting all this, as these are the similar pixels. Okay, so you'll get only the object. Now this particular object, we can find a bounding box, and we can identify the center of it, and this particular object we can actually trace from the coming frames with the help of Kalman filter. So what I did basically, uh, I detected the object. Okay, and we have this angle, we have this, let's say, the positions in which the displacement which the one frame and the frequent frame is having, and based on that we are and the angle in which it is going. Okay, so based on that we are actually calculating and implementing that. So it is basically the standard of physics which we use. Okay, so similar to that we have used. So I'm not like very fresh to it. I'm just giving an overview of it. So in that way, we were able to do that. So Kalman filter was very much used, I guess, in missiles tracking also. I need to check that, but yes, it is very like nice thing to learn about. But it just that the mathematical implementation is there, so you need to go through it. I'll be sharing a demonstration video for the Kalman filter, how to code for the Kalman filter. Yes, we can. Arjun, we can actually do that, no doubt. But it gets kind of impossible when you actually deal with. Basically, we are doing over here is a trajectory prediction. Okay. Yeah. So he'll be with the previous assignments.
Actually, we are doing the trajectory prediction only in
Huh.
every step.
Uh, yes, Pradeep. I'll share that code. Okay. 8x8 matrix. Yeah, I'll share that. I'll be sharing the demonstration thing with you.
Yeah,
Yeah. So this is
I'm just
again an
showing
actual.
the yeah, I'm just showing the how it is predicting the trajectory while we are moving the cursor in at every point. See, I am moving my cursor, so in each and every part, it is trying to move out to see for the trajectory possible in every state. So as now this is the present state, and now we have to calculate for the next step. As soon as I try to move in another direction, see my cursor is moving in forward direction. So in every step, it as it is an iterative process. In every step, it is trying to calculate for each and every possible trajectory at that point. So likewise, it is moving and it is predicting that I will go in particular direction on the basis of the present input and the previous my previous experience. So likewise, it is predicting. This is just to show the how it is and calculating all the steps in each all the step by step in every. Yeah, that was it. So this is the open source, you can see from here also. Yes, ma'am, the trajectory would be from the mouse straight only, and pass it from here.